In the last video, we learned the basic equation for a circle. We learned that it is x squared plus y squared equals the radius squared. We learned where that came from. We learned how to make a right triangle inside a circle, and learned where the x squared and the y squared and the r squared came from using the Pythagorean theorem. Now we are going to move on to circles that don't have a center at 0, 0, that don't have a center at the origin. So here is a circle that you can use the circle tool to make or draw it on graph paper. It has a center not at the origin, it has a center at 3, 1. And it has a radius of 5 units long. Okay. So you can draw a right triangle just like we were doing before. Point P represents a point on the circle with no special characteristics. We don't know the x value of point P or the y value of point P. We've drawn our right triangle. Okay, line segment PB. What is the length of line segment PB? Write an expression. So line segment PB is right here. And we're to write an expression to represent that length. Okay, that is, let's call that x. Nope, we're not going to call that x. Because let me show you what x is. This is x, right? Or actually it's y. Let's call it y. From the x-axis here up to here is y. Right? Now, from the x-axis to the bottom of our triangle, how many is that? That is 1. Here's, it's not writing where I want it to write. It's 1. Okay, this is 1 unit long. Okay, so if we want to talk about, well, what is just the length of line segment PB? Let's make that a different color. If we want to talk about just this part right here, well, we're taking the whole blue line, y, and we're going to subtract out that little red piece, which is 1. And that leaves us with y minus 1. So I'm going to say line segment PB is y minus 1. Okay? Now, I want you, before I do it, to try to find the length of line segment AB. Okay, so pause the video for a second and try to find the length of line segment AB the same way we found the length of line segment PB just now. Okay, so let's use the same technique. Let's start with this line right here. The whole thing. How long is that? Okay, well that's x. Okay. Now let's do from here to here. How long is that? Well, we can see how long that is because it ends right here, right? That's 3. So if we take the whole red thing, the whole red line, and we subtract out the blue line, what we're going to have left is line segment AB. So we're going to call that the whole red line x minus the blue line, which is 3. So the expression for the length of line segment AB is x minus 3. Okay. Use your expressions for line segment PB and line segment AB, along with the fact that the length of the radius of the circle is 5, to write an equation for this circle. Okay? So, if their original equation for a circle that had a 0 origin center was x squared plus y squared equals radius squared. Okay, well, what are we going to do about the fact that this isn't x anymore? This is x plus minus 3. And this isn't y anymore. This is y minus 1. So what's our equation of this circle going to look like? Well, I think it's going to look like this. X minus 3 squared. We're still using Pythagorean theorem, right? Plus y minus 1 squared. So leg squared plus leg squared equals hypotenuse squared, which is the radius. The radius is the hypotenuse. Or, in final form, we could make it x minus 3 squared plus y minus 1 squared equals 25, not 25 squared, equals 25, because 5 squared is 25. Let's practice. Find the equation of each circle represented below. Number 1, the circle with the center 2, 7 and the radius of length 1 unit. Pause the video and try to solve number 1. Come back and see how you did. Okay. If the center is 2, 7, the x value, come on, is 2 on the center, and the y value on the center is 7, and the radius is 1. 1 squared is just 1. Okay, go ahead and give number 2 a try, see what you come up with, come back and unpause the video and check it out. Okay, it looks like the center of this video, or I'm sorry, of this circle Right here, it looks like the coordinates for the center are 3, 4. And it looks like the radius is from here to here. The radius is 2. So we're going to have a circle of x minus 3 squared plus y minus 4 squared, and the radius squared, 2 squared, is 4. Okay, how about number 3? Go ahead and pause the video and give that one a try. All right. This is not telling us the radius, and it's not telling us the center, so we're going to have to find both of those. Okay, so 6, 0 and negative 6, 0 are the endpoints of a diameter. So let's figure out how long our diameter is. Because if we know how long our diameter is, we're going to know how long our radius is, right? Because a radius is just half of a diameter. So, distance formula. Diameter equals 6 minus negative 6 squared plus, and this is just 0 minus 0 squared, right? Equals 6 minus negative 6, that's 12. 12 squared is 144. Square root of 144 is 12. So my diameter is 12, which means my radius is 6. All right, well, in order to find the center, we got to find that midpoint of that diameter, right? So let's find the midpoint of these two endpoints, and that'll give us the center of the circle, because you know a diameter goes through the center of a circle, right? So the midpoint would be 6 plus negative 6 divided by 2, comma, 0 plus 0 divided by 2. So 6 plus negative 6 is 0. Divided by 2 is 0. The midpoint 0, 0, 0, comma 0. So that's the center. So what does a circle look like with a center at the origin? Let's go back to the very first equation we learned. At the origin it looks like this, and 6 squared, radius squared, is 36. Hope that's helpful to you. Reach out if you have any questions about circle equations.